For question number 128, we have been asked to find the value of minus 2 by L, where L is the value of limit x approach 0, x ln x plus 2x ln sine 1 by root x. For solving this limit, since here it is given 1 by root x, we take a substitution that x can be taken as 1 upon theta square. Now as x will approach towards infinity, theta will approach towards 0. So we can write L as limit theta approach 0, 1 upon theta square ln 1 upon theta square plus 2 over theta square ln sine theta. So L will also be equals to now limit theta approach 0 ln 1 upon theta square. That can be simplified to minus 2 ln theta over theta square plus 2 over theta square ln sine theta. Taking the LCM as theta square, we get L is equals to limit theta approach 0, denominator we get theta square, and we have 2 ln sine theta minus ln theta. 2 is also taken as common. This 2 can come outside, and we get 2 ln theta approach 0 ln sine theta minus ln theta upon theta square. This is L. Now as we can see, ln, and this can be written as sine theta over theta. When theta will approach towards 0, it will become ln 1, and that would be 0. So the form of this limit would be 0 by 0. We can apply L'Hopital's rule in this. So we can say, using L'Hopital's rule, L would be equals to 2 limit theta approach 0 ln sine theta. The differentiation would be cos theta over sine theta minus ln theta, differentiation would be 1 by theta, and for theta square that would be 2 theta. So the value of limit L would be 2, and this 2 also comes outside. Limit theta approach 0 1 upon tan theta minus 1 over theta over 2 theta. Now we'll take LCM, and this value will also come in multiplication with this, and 2 and 2 that can be cancelled. So we can write this value L as L equals to limit theta approach 0 theta minus tan theta over, and from the LCM we get theta square tan theta. Okay, this 2 had come outside, so we get this. And now for this tan theta, we can multiply and divide a theta, so that as theta will approach towards 0, this will become standard limit 1, and we get L is equals to limit theta approach 0 theta minus tan theta over theta cube. This is also a kind of standard limit that can be solved using expansion of tan theta, and its value L will come out to be minus 1 by 3. Since we were asked minus 2 by L, so minus 2 by L will be equal to 6, and that gives us our answer as option number B. For the consistency of this system of equations, we need to have these 3 lines as concurrent, and for concurrence, the determinant formed using coefficients of these 3 equations, the value of that determinant should be equal to 0. So we write the determinant formed using coefficients as C 1 1 1 C 2 1 1 and 1. The value of this determinant should be equal to 0 for consistency of system. So on solving this determinant, it will give us C into C minus 2 minus 1 into 1 minus 2 plus 1 into 1 minus C is equals to 0. On simplification, this equation will give us C square minus 3C and plus 2 is equals to 0. This gives us two values of C, that are C is equals to 1 and C is equals to 2. Now on getting these two values of C, we need to check if our system does not give us any extra result. So for checking at C is equals to 1, we put C is equals to 1 in the given equations. We get x plus y plus 1 is equals to 0, x plus y plus 2 is equals to 0 and x plus y plus 1 is equals to 0. Two of these lines become identical while this one line is parallel to these two lines. So that system will not be consistent. So c equals to 1 should be rejected. At c equals to 2, we get 2x plus y plus 1 is equals to 0, x plus 2y plus 2 is equals to 0, and x plus y plus 1 is equals to 0. None of these three lines are neither parallel, so we can say c equals to 2 can be our solution. For question number 130, we need to find the locus of centers of circles that touches these two lines. These two lines, as we can see, they are not parallel. So these two lines will be intersecting, and any circle that touches these two lines, that should become like this in this region. It can also be in this region, or it can be here. Meanwhile, the center of this circle, that locus should lie upon the angle bisector of these two lines, and this center also will lie on angle bisector of these two lines. So for finding the locus of center, we can find the equation of angle bisectors of these two lines. So for writing the angle bisectors, we can write it as 3x plus 4y plus 1 upon under root of 3 square plus 4 square is equal to plus minus, and this equation 4x plus 3y minus 5 over square root of 4 square plus 3 square. On simplification, we can get the equation of two bisectors. These two lines, they will give us a union of two straight lines. That would be answer number D. Number 131st, we have been given a geometric progression whose nth, n squareth and n cubeth term have been given as root 2, 2 root 2 and 64 root 2. This is a geometric progression, so we can assume its first term to be a and its common ratio to be r. So we can write the nth term as a into r raised to power n minus 1, t n squareth term as a into r raised to power n square minus 1, and t n cubeth term that can be written as a into r raised to power n cube minus 1. We can name that as equation number 1 and 2 and 3. We need to solve these three equations to get the value of three unknowns. Those are a, r and n. So for solving, we can do things like dividing equation 2 by equation 1. What we get is here 2 root 2 over root 2 is equals to a into r raised to power n square minus 1 over a into r raised to power n minus 1. These things can be cancelled out, and we get 2 is equals to r raised to power n square minus n. That can be termed as equation number 4. Again, we can divide equation number 3 by equation number 2, and what we get here is 64 root 2 upon 2 root 2 is equals to a r n cube minus 1 over a r n square minus 1. Again, terms can be cancelled out. What we get here is 32 is equals to r raised to power n cube minus n square. That can be named as equation number 5. So now for equation 4 and 5, we have two unknowns. Those are r and n. These two equations can be solved because 2 and 32. 32 can be written as 2 raised to power 5. So for solving these two equations, what we can do is we can write 2 raised to power 5 is equals to 32, which implies r n square minus n raised to power 5 is equals to r n cube minus n square, and this will give us, since the bases are same, this will give us 5 into n square minus n is equals to n cube minus n square. This equation can be very easily solved. It will give us three values of n is equals to 0, 1 and n is equals to 5. Since in the question n is given to be a natural number, hence n is equals to 0 will get rejected. Again, n is equals to 1 if we take, then we get first term as three testing terms. So n equals to 1 cannot be the answer. So we have only value of n, that is 5, and we have been asked number of geometric progressions. So for n equals to 5, we get just one geometric progression. That gives us answer B.